Hey, welcome back to this episode of creating a neural network from scratch in Java. Today we are going to look at the max pool layer. So what does the max pool layer do? Hopefully you have kind of a bit of a background, you've done your homework, you already know all this, but what it does is it kind of slides a window over our input and takes the maximum value in that window, and that becomes our output. So you can see here we have a step size of 1 and a window size of 2, so a 2 by 2 square, sliding over our input image. In the square the maximum is 1, in the square the maximum is 2, in the square the maximum is also 2, so this 2 can feature in more than one output, I guess, and you can see it's also the highest number here and here. For backpropagation we want to get our error, so our dl by do, back into the right place. And because our max pool doesn't change any values, it just kind of takes them and puts them in the right place. So let's say this is our error, our dl do11. So this corresponds to the last output, so this 1 here. Where did this 1 come from? It came from this maximum value up in here. So we put our error back where that 1 came from. Similarly for this 2, so this is our dl do12. So whatever went here, what was the error for this? Well, that error came from our maximum in this window, which was that 2. So we put that error for dl do12 back here. Now, as I said before, one value can be the maximum in multiple slides. So in this previous example, this 2 was the maximum for this window, this window, this window, and this window. So when we slide over to figure out what is dl do here, we're adding it to this error in 2. We're sending it back to wherever the maximum value came from, if that makes sense. So we're just passing the errors back to the previous layer where they came from. Super straightforward, way more straightforward than our fully connected layers and convolution layer backpropagation. So if this is our input, we can see our dl do11 came from here, so that goes back to there. And for 2, it contributed to all of these different errors because it was the maximum in all of these different windows. So we add all of those up. Cool, so that's max pool, forward pass, and backprop. Let's code it. And let's create our second layer. Call it max pool layer. So similar to all our previous layers, this is, max pool layer is going to extend our abstract layers class. We're going to get a bunch of errors here. Hey, it doesn't have these methods. Go ahead and implement them. So what does our max pool layer want? Well, we're going to give it a step size, so how many steps that window takes along, and the window size, so how big the window itself is. So let's create some variables to hold that information. And we're also going to have an input length, the number of input rows, and the number of input columns, because this is going to be used to calculate our output length rows and columns. Let's go ahead and create our constructor. Max pool forward pass. What does the forward pass look like for this? Well, we're going to return a list of matrices. And we're going to take a list of matrices as input. So basically what we're doing is we're taking these lists of images that we're getting in, our filtered lists, or whatever the previous layers have done, and we're taking the maximum, most interesting, most important values from those points and just spitting them back out in kind of like a condensed matrix, I guess you could think, like a condensed image. So anyway, we're going to want our output. And then we're going to want to make like a pooling function. So what does a pooling function look like? So this is just going to pool one image. So just get the maximum values from one image rather than our whole list. Up here we can just do for we can just add to the output the result of each pull for each input. Now, for the pulling method itself, let's create our output. And how big is this output going to be? Well, it's going to be get output rows multiplied by get output columns. Now we haven't implemented those yet, so let's go do that now. Our output length is going to be the same size as our input length because for each input image we're going to pull it. We're going to take the maximums from it. So we're going to return in length. For our get output rows, we are going to return our in rows minus the window size. So you can kind of draw this out and do the math yourself, but this is how it works out. Divided by the step size plus 1. Cool. Same thing for the output columns, except we're doing in cols. Sweet, and then the elements is just multiplying all of these together. Easy. So now we know our output size. So coming back to here, we've set our output using these new functions for getting our output size. So now let's slide our window across the image. So what this is saying is for each row, we're going to add our step size to the row every time we do this check. So if our step size is 1, that's the same as kind of incrementing our index by 1. And we'll do the same thing for the columns. We'll set our max to 0, and then anything above 0 will become our new maximum. And then around this window we're going to get whatever the maximum is. So for each of the elements in our window, in our example that was that 2x2 square. So for each element of our window, we're going to check if the maximum value at this point is, if the maximum value is less than the value at this point. And if it is greater, then we'll set the max to be the new value at this point. After that, we will set our output at R and C to that value. And finally, returning our output. Cool, so that's our forward pass. So for backpropagation, remembering the goal is to put the errors back to the place where they came from. So what we want to do is actually have a way of remembering where exactly this maximum was at that point. So what we're going to do is create 2 arrays. One is going to keep track of all of the x coordinates, so what row was the maximum, and one is going to keep track of all the column coordinates, the y coordinates, what column was that maximum from. So that when we go to do our backpropagation, we can check where that maximum value was and send the error back to that. Let's create those arrays now at the top. So this is storing all the x coordinates, this is storing all the y coordinates. So in here, let's track for this particular input where our max rows and columns are coming from. So every time we find a new maximum, we are going to set our max row at RC, our max rows at RC to be equal to whatever coordinate we just found that value at. So we're going to set it to r plus x, and then max columns colon. So by the end of this we will have kept track of where our rows and columns are. Now if we don't find a maximum, we kind of still want to have values here that kind of indicate that. So let's just, before we change these, set them to -1. So then we're going to add these max rows and max columns values to our list. So let's go ahead and do that. Sweet, so now we're tracking the coordinates of where these maximum values came from. So let's start on that backpropagation function. So we want to find our dxdl for our previous layer. That is one priority, dxdl. And this is going to be a list of our doubles. So it's going to be the same dimension as our input, because it's always dxdl corresponds to our input. Equals new array list. Sweet. Then we're going to have int l equals 0, and this is just going to say how far through our list we are. And then for each array in that list, we're going to calculate the error. So how do we do this? Well, for each of our, I guess, error inputs from the previous layer, we're going to find out where that came from, and everything else in our array will be 0, but we're going to find out where that error came from and set that to be the value of this DLDO. We'll actually sum it, because like we saw before, sometimes one coordinate can actually hold a really high value that becomes the maximum in lots of different steps. We're going to get whatever the coordinate was for our max I coordinate, I guess, our max X coordinate. And then here we are getting whatever the last Y coordinate was. So whatever column that came from. And then if the max I does not equal -1, so if there was a maximum that wasn't 0, that wasn't less than 0, we're going to set our error at that corresponding coordinate to where our maximum was. And we're just going to add our error array value at that point. Cool, so now we've set all our errors into this array. They're at the right place, they're corresponding to wherever that maximum value was. So let's, because we're doing this for every input, let's add that to that list. So dxdl dot add error, and then increment l. So we're moving to the next item in the list. And that's our completed error list. Now all we need to do is pass that back to the previous layer so that it can do its updating. So if previous layer does not equal null, Sweet as. So here's our backpropagation for our list of matrices. What's our backpropagation for our one-dimensional vector? Well, we just convert it. So we're converting it back to a vector, but we want to know, so what shape is it? It is the shape of get output length, get output rows, get output columns. So this is what we expected our output to be shaped as, and so that'll be the same as our error per output, our DLDO. And then we're just going to call backpropagation on the matrix list. Sweet. Now I don't think we did the same thing for get output, so let's sort that out. So for get output, we're going to have a list double output equals max pull forward pass of our input. Well, let's call this pull output pull. And if we have a next layer, well, actually we have to have a next layer because our last layer is always going to be the fully connected layer. So I would add like a check here and maybe throw an error, but honestly we don't need it because we can make this assumption. But then we'll do next layer dot get output of our output pull. So just passing that through the layers to get our final guess. And we will return whatever the next layer throws at us. Cool, and then similarly here, we are just going to convert our matrix list. Obviously the dimensions of this are going to be different, so this is going to be our in length. And we're going to return get output on matrix list. So this function just calling this one. And that about does it for our pulling layer, forward pass, and backpropagation. Alright, so a little note for our pulling layer. This is a bug that I didn't see until the very end. We need to initialize these last max row and last max column. We need to go ahead and do that when we are doing our forward pass. Yeah, so in here we totally forgot to initialize our last max row and last max column array lists. So join me next time and we'll take on the big daddy convolution layer. Max pull layer is easy in comparison, but you're starting to get an idea of how we're working with matrices. But yeah, I'll see you then. I'm losing light, so expect a costume change between now and then.